Okay, in this video, I'm going to graph cosine, y equals cosine theta in radians. So again, we'll do it between 0 and 2 pi. And again, just like when we did the y equals sine graph, you probably know what this looks like. And again, it's the horizontal, the radian, or the theta scale, which is going to be different than what you are used to. So we're going to go from 0 to 2 pi. So 0 would be here at the y-axis. 0 is there and 2 pi is there. And you just have to decide which sort of theta values you want to make sure you put on your graph. Halfway between 2 pi and 0 is pi, so that's an important point, so we'll make sure we put that on your graph. And halfway between 0 and pi is half of pi, or pi by 2. We'll put that one on a graph, and then halfway between pi and 2 pi is 3 pi by 2. So now, when we did the sine graph, I said in between 0 and pi by 2 is pi by 4, so we put that one on our graph. I'm going to do this one slightly different, just so you see other key points. So when we did halfway between 0 and pi by 2, we did pi by 4, so we only had one key point between 0 and pi by 2. Here I'm going to do two key points between 0 and pi by 2. So what I'm going to do is divide pi by 2 by 3. Pi by 2 divided by 3 is pi by 6. So a third of the way between 0 and pi by 2, I'm going to do pi by 6. And then the next scale mark would be double that, so pi by 6, and if I count by pi by 6, this would be 2 pi by 6. But if you reduce 2 pi by 6, you get pi by 3. And then the next one would be 3 pi by 6, but that's just pi by 2. Right, that reduces to pi by 2. The next one would be 4 pi by 6, or 2 pi by 3. And the next one would be 5 pi by 6. And then the next one would be 6 pi by 6, which is pi. Right? 6 pi by 6 reduces to pi. So here my scale is pi by 6s. I'm going up by pi by 6s. This one would be 7 pi by 6. The next one would be 8 pi by 6, but that reduces to 4 pi by 3. And the next one would be 9 pi by 6, which reduces to 3 pi by 2, which is already there. Then 10 pi by 6, which reduces to 5 pi by 3. And then 11 pi by 6. Okay, so my scale is it's a little different. This time it went up by pi by 6s, whereas on the sine graph I went up by pi by 4s. No real difference. The nice thing about going up by pi by 6s is you get more points, you get more key points. It's a little more accurate, but you do have to graph more points here. So that's theta, and this will be y. So theta pi by 6, pi by 3, pi by 2. Here, I'll pause while I fill in this. Okay, so I got a lot more points in my table of values, but I'm just going to sub in these theta values into cosine theta. So cosine of 0 is 1. Cosine of pi by 6 is root 3 over 2. Cosine of pi by 3 is 1/2. And cosine of pi by 2 is 0. Okay, this is basically our first quadrant, right? It's the first quadrant. So now everything's just going to be similar, but negative values, yeah. So 2 pi by 3, I'm going to get negative 1/2. Negative root 3 over 2. And then for pi, I'm going to get negative 1. So that's the second quadrant. In the third quadrant, I will get minus root 3 over 2. minus 1/2, and this would be 0 again. These are all special triangles, so you should know them. This one will get a half, this one will get root 3 over 2, and this one I will be back at 1. So now I just need to plot these points on my graph. Root 3 over 2, you might want to work out what that is. It's 0.86 approximately, or 0.87 it actually rounds to, sorry. So almost 0.9, but let's go and put these on a graph. So at 0, we're at 1. At pi, we're at negative 1. At pi by 2 was at 0. At 3 pi 2 is at 0. And at 2 pi it was at 1. Pi by 6, we're at 0.87. So it's somewhere around there. At pi by 3, we were at half. That's about there. 2 pi by 3 was negative half. And 5 pi by 6, it was negative root 3 over 2. So let's keep going. 7 pi by 6, it was also negative root 3 over 2. You were at negative a half. Already put this one on there. This one was at a half. And this one was at 0.9. 0.86. So it's going to look something like this. So that's our cosine graph. Y equals cosine theta. That's one cycle, right? We start at 1, end at 1, so that's one complete period. So just like with the sine graph, you've got some key features here. Your period, 2 pi. Your amplitude, was 1. Amplitude is the distance between the middle and the highest value, or the smallest value. And then your equation of axes. And that's sort of that middle horizontal line. So in this case, it's y equals 0. And those are the key features that we're going to need for graphing transformations of this cosine graph. I'll say it here, it should be a little more curved than I got going on here. A little more like that. That's probably just my scale. Made my points off a little bit, but it should be something like that.